Hello everyone. In this third tutorial, I'm going to show you how to run Optocomb ScanSoft, QTIA's data acquisition software. I will also show you how Optocomb ScanSoft works hand in hand with the rest of the Optocomb Suite to automate the data processing, the data analysis, and the GD&T assessment, the quality control of your part. So today we are actually going to scan sprockets with QTIA's L90 Optocomb sensors integrated on an XYZ stage. For the purpose of this tutorial, we'll load the sprockets manually, but we of course offer fully automated inline solutions that work similarly. So let's start. This is a user interface of Optocomb ScanSoft. Here you can choose the stage you want the software to connect to. Here are data saving parameters. You need to choose a data saving folder as well as a data file name. So let's say sprocket. Then you need to make sure that your sensor is not too much out of focus. So we click here on this button, and here you can move the sensor head up and down to maximize the intensity of the reflected light on the sprocket surface and find the focal plane. L90 can actually measure within a 3D box that is 130 mm high, so it is not such a sensitive parameter here, but it is better to check it for the very first part you want to inspect, just in case. Once you have found the focal plane, you can click OK. So the next step is defining your scanning area. L90 performs a line scan, so you need to move the part with respect to the sensor in order to obtain a full 3D profile of the sprocket. You just need to choose the start point and the end point. The start point here, for example, and the end point here. And the software will make sure to measure the whole 3D box defined by those 2 points. You can then set the scanning pitch. Here we choose 100 micrometers in both directions. There are more scanning parameters, but it will work just fine like that. Note that you can also save and load scanning parameters with those 2 buttons. And that's it. You are ready to scan by clicking this button. So the scan takes about 6 seconds, and the software automatically outputs the 3D data. Here's the 3D data. And here, this is the reflected light intensity in logarithmic scale. You then save the data in either a binary, STL, or CSV format. And you can readily visualize the sprocket in 3D and use the data for the parts quality control. Yeah, it looks like this. Now, in the previous tutorial, I showed you how to use QTIA's Optocomb ruler to automate the GD&T analysis of your part. Here, I'm going to show you that Optocomb ruler can synchronize with Optocomb ScanSoft to automatically perform the dimensional inspection of sprockets scanned by the L90 sensor. So let's open Optocomb ruler and load the sprocket inspection recipe. This recipe assesses the diameter and the roundness of bores and also the sprocket thickness. We then need to click the automated inspection button, choose the data folder, and Optocomb ruler will run the inspection recipe on all data files that are created in that very folder. So let me reduce the Optocomb ruler in the window on the bottom right of your screen so you can see what's going on as I scan the sprockets. I make sure to select the autosave data options. And then I'm ready to scan again this first sprocket. The scanning of the sprocket will take again about 6 seconds. Here we go. And as Optocomb ruler performs the sprocket inspection recipe, We run the next scan with Optocomb ScanSoft. The result of the first sprocket's inspection is output as the second sprocket is scanned, and it's a pass for all inspection items. We run 4 consecutive sprocket scans and obtain 4 different inspection results depending on the sprocket quality. The second sprocket seems to have a problem with the roundness of one of its pores. The third sprocket is now being scanned. Again, it takes about 6 seconds to scan this sprocket. The third sprocket has a problem with its thickness. And let's scan the fourth sprocket. Okay, let's wait for the full sprocket to be scanned. Okay, so the last one is also a fail because of the sprocket thickness. So we have shown that the data analysis can be automated and carried out in parallel to the part scanning. For maximum efficiency, you of course want to integrate our Optocomb sensors in line so that the parse loading is also automated. This concludes today's tutorial. If you want to learn more about our 3D metrology and quality 4.0 solutions, I encourage you to check kutia.co.jp.